So more solving equations. Excuse me. We're basically going to do two different types of problems. Okay? So here we go with our first one. Go ahead and try that one on your own. What do I do first? Subtract m. Okay. So I'm left with 1. What do I have here? Plus 2m equals 5 and nothing there. Now what? So I have 2m equals what? Now what? Divide by 2, and I get m equals 2. Easy, right? Okay, you try number 2. What do you notice about this one? It's not impossible. If I combine the p's on the same side, negative p and positive p cancel. What about 7 and negative 7? They cancel. So if everything cancels, what does that mean I have? It means I have 0 on that side. Right? This whole side becomes 0. What is this side? It's still p plus 5. Now, when I said, what do I have? I did hear someone say p plus 5. You can't lose that equal sign. The equal sign never disappears. The equal sign has to be in every single step. That's why it drives me nuts when I see people showing their work and they're just like, oh, I'm just going to subtract 5 here, and I get and I get, what, 5 minus 5? I get 0. Well, no, your equal sign is a part of the problem. It has to continue on. Yes, you subtract 5, but my subtraction property of equality says what? If I do it to one side, you got to do it on the other side. So you got to show that. And hang on, 0 minus 5, my answer is not 0. It's going to be what? Negative 5. So my answer should always have a letter equals a number. Okay? Now, I know when we type it into the computer, we just type in the number for ease. But you got to keep your stuff together here if you're going to follow the problem all the way through. Okay? All right, now try this one. Actually, before you try that one, I'm covering it up. Before you try that one, let's talk real quick about what the answers mean. What does the answer m equals 2 mean for that equation? Like if you had to interpret that, what would you say?
Well, wherever the variable m is, you would place 2 in.
Okay, so if I put a 2 here, and I solved this side, and I put a 2 here, and I solved this side, that both sides would give me the same answer because they're equal, right? What if I plugged in m equals 5? Would I get this side to equal that side? No. I would get a different number on this side than on that side. Okay? Over here, the only way I can get this side to equal that side is if p is negative 5. No other number will do it. See if you can solve this one then. Is there anything funky going on here? (5a minus a), what's that?
4A.
Because they're on the same side of the equal sign, right? And then I have minus 6. What's going to happen? If I subtract 4a from both sides, 4a cancels there and it cancels there. Well, let's look at what's left over. My equal sign is part of the answer, remember? What's left on the left side here? Negative 6. And what's left on the right side? Is that a statement that you would say is true? Mm-hmm. What that statement means is that my answer is what we call all real numbers. And yes, it's important to write real because there is an opposite of real called imaginary that you deal with in IM3. Okay? And imaginary numbers would not fit this criteria. So what does this answer mean? If this meant that I had to plug in 2 and that would give this side equal to that side, what does this mean?
Any number you plug in.
Any number I plug in will make this side equal to this side. So if I plug in a equals 7, here, here, and here, left side's going to equal the right side. I don't know what it is, but it's going to be equal. If I plug in 10, left side's going to equal the right side. If I plug in 50, left side's going to equal the right side. If I plug in negative 236, left side's going to equal the right side. All real numbers will work for A in this equation. All right, try this way. If I go to get my V's together, I'm going to subtract V. And that leaves me with what? No variable, but I had no variable here also. What's left? 6 equals negative 1. Is that the same situation as this?
No.
Why not? This isn't true. This was true. This is not true. If I have $6 and you owe $1, we do not have an equal amount of money. Right? That is not a true statement. What that means is my answer is, what does that mean? There is no number that you could plug in that would make the left side equal to the right side. Okay? Now, what drives me nuts is as soon as I introduce a problem that has an answer of no solution, it's like the lazy people's happy day because the lazy people just write no solution for every answer. Not joking, that does happen. It's really disgusting. There is a big difference between no solution and all real numbers. I need to see the work getting down to the statement, something equals something, so that I see the justification for which answer you are choosing. Does that make sense? Okay. I'm going to give you 2 more to do, and then we'll move on to the second type of problem that I need to show you today. Okay. Negative 14 plus 4x equals negative 4 times negative x plus 4. And then the last one, I'll scoot it up for you. Oops, don't need parentheses there. Go ahead and try those 2. All right, I'm gonna start working through, see if your answers match mine. First thing I need to do here is distribute. Yeah? Next, I get my x's together. When I get them together, they cancel. So I have to look at what's left. What's left on the left? Negative 14. And on the right, that statement, negative 14 equals negative 16, is false. Therefore, my answer is so. Okay, over here I'm going to distribute also. That's going to give me positive a minus 5 is equal to negative 5 plus a. And when I try and get my a's together, what happens? They cancel. And I'm left with negative 5 on the left and negative 5 on the right. That statement is true, which means what's my answer? Okay, questions about that? That is what we call our special cases. Now we're going to move on to literal equations. Okay, literal equations. So, here is my first one. A minus C equals D minus R. There's no numbers. Literal equations don't have a lot of numbers. Sometimes you might see a number in there. But for the most part, we don't have numbers. So there's always going to be some kind of a statement that is telling you to solve for a certain letter. What does it mean to solve for something? Get A by itself. So all of our problems that we've been doing so far has been get X by itself, get M by itself, get P by itself. When it says solve for A, that means get A by itself. So if I look at A, here's my equal sign. So there's only one thing that's making A not be by itself. What is it?
C.
A minus C. How do I get a minus C to go over here? I add C to both sides. Does it matter where I put it? It doesn't have any like terms there, does it? So I'll just tack it on at the end. And I have A equals D minus R plus C. I have just solved for A. It's the exact same steps we've used before, just using letters instead of numbers. Okay? Sometimes you may notice that some of these literal equations are familiar to yourself. Yes? Question?
Is there a way for you to explain it more?
Is there a way for me to explain it more? Let's see. If I had A minus 3 is equal to X minus Y. Do you see that this is exactly the same as this? I just have different letters and stuff. If I had to get A by itself, it doesn't matter what's over here, right? It only matters that there's a minus 3 here, and that's the reason why A is not by itself. Very quick. Small one. So if I need to get A by itself, I need to move the 3, don't I? How do I do it? I add 3. Can I add the 3 to either of those letters? No. So I just have X minus Y plus 3 equals A. Exact same thing as what I did here. I just used a letter instead of the 3. Okay? All right, let's look at another one because these come in all different types. Z equals my over x. Solve for x. What do you notice about the x? It's on the bottom. What do we usually do to get rid of a denominator? We multiply by the denominator. Now, that might seem a little odd because if I multiply by the denominator, it's going to cancel off, and I don't usually want to cancel my variable there. However, it cancels here, but it shows up over here. So now I have zx equals my. Is x by itself? So what do I need to do? Looking at the x, I need to get rid of the z. The z is connected by what? Multiplication. So what's going to get rid of multiplication? So I divide by z. X is equal to my over z. These are kind of weird. So. I got two more of these. So again, if I look just to the left side, what's the issue? The c. How do I get rid of the c? Divide by c. Now over here, there's two different things. So I have two different options. The easiest option is just to go, boom, divide the whole thing by c at once. Cancels out over there. X is equal to r minus d over c. My other option, just so you're aware, if I had xc equals r minus d, when I go to divide by c, I could divide each part by c, and that actually, even though it looks different, means the same thing. So either one of those are correct. This is just the easier one. You would want to do it this way if there was something that might reduce. But if nothing's going to reduce, this is just the easier way to go. Okay? All right, last one. I got to get the x by itself. So, when I need to get the x by itself, don't we usually get rid of the other term first? So how would I move the y over? I would subtract y. That gives me g minus y is equal to negative cx. Is x by itself? No. So what do I need to do? Divide by negative c. And again, I could do it either one of these ways, but I'm going to do the easy way, divide by negative c, like this. So I get x equals g minus y over negative c. Okay. All right, those ones are a bit tricky. Might take you a minute, but your homework posted on Google Classroom. It's a mixture of both these literal equations and the all real numbers, no solutions ones. Happy studying.